La Niña is one of the most fascinating natural phenomena that profoundly impacts weather patterns across the globe. It's a term you might have heard in conversations about extreme weather events like heavy rains, floods, or even droughts. But what exactly is La Niña, and why is it so important to understand? At its core, La Niña is a climatic event that cools the waters of the Central and Eastern Pacific Ocean, influencing the atmosphere and weather systems around the world. It's part of a larger cycle called the El Niño Southern Oscillation, ENSO, but unlike its counterpart El Niño, La Niña often brings colder conditions and unique challenges. Understanding La Niña is crucial because it affects millions of lives, from farmers whose crops depend on stable weather to coastal communities bracing for more intense storms. Its impacts are not limited to specific regions, the ripple effects are felt everywhere, from Asia to the Americas. In this video, we'll explore the science behind La Niña, its causes, and the dramatic effects it has on our planet. We'll also look at how it has shaped major weather events in history and what we can do to adapt to its challenges. Stay tuned as we unravel the mysteries of this powerful natural phenomenon. La Niña is a climate phenomenon that occurs when sea surface temperatures in the Central and Eastern Pacific Ocean drop significantly below average. This cooling of the ocean influences atmospheric conditions, leading to changes in weather patterns across the globe. La Niña is a critical part of the El Niño Southern Oscillation (ENSO) cycle, working as a counterpart to the warming effects of El Niño. During our La Niña event, stronger than usual trade winds push warm surface waters westward, causing colder water from the ocean's depths to rise to the surface near the equator. This process, called upwelling, amplifies the cooling effect in the Pacific. These changes in the ocean and atmosphere set off a chain reaction, impacting jet streams and air pressure systems, which then alter global weather patterns. What makes La Niña fascinating is its ability to influence diverse climates in opposite ways. While some regions experience above-average rainfall, others face severe droughts. For example, Southeast Asia and Northern Australia typically see heavier rains, while parts of South America endure drier than usual conditions. La Niña isn't a single event but a recurring cycle, usually lasting 9 to 12 months, though it can persist for longer. Its frequency varies, often occurring every 2 to 7 years. Despite being a natural occurrence, La Niña's effects can be intensified by other factors like climate change, making it essential to study and understand this phenomenon. By understanding what La Niña is and how it operates, we can better prepare for its impacts and minimize the risks it poses to vulnerable communities worldwide. La Niña is primarily caused by changes in the interaction between the atmosphere and the Pacific Ocean. The process begins with stronger than normal trade winds, those steady winds that blow from east to west along the equator. These intensified winds push the warm surface waters of the Pacific Ocean further westward, toward Asia. As this happens, cooler water from the deep ocean rises to the surface near South America, a process known as upwelling. This drop in sea surface temperatures disrupts the balance of heat and moisture in the atmosphere. The cooler waters in the eastern Pacific result in lower air temperatures above them, creating changes in air pressure. This, in turn, influences the position of jet streams and global wind patterns. These shifts lead to the unique weather conditions associated with La Niña, such as increased rainfall in some areas and drought in others. Interestingly, La Niña often develops after an El Niño event, when the Pacific Ocean transitions from unusually warm to unusually cool. However, the exact triggers for these transitions are complex and not fully understood, as they involve multiple factors like ocean currents, atmospheric pressure changes, and even the Earth's rotation. While La Niña is part of a natural climate cycle, its frequency and intensity can vary, influenced by other long-term climate patterns. Understanding its causes helps scientists predict its occurrence and prepare for its global impacts. La Niña significantly impacts weather patterns around the globe, causing dramatic shifts that can affect millions of lives. These changes occur because the cooling of the Pacific Ocean alters atmospheric conditions, influencing how wind, moisture, and air pressure behave across continents. One of the most noticeable effects of La Niña is the increase in rainfall in certain regions. Countries in Southeast Asia, Northern Australia, and parts of India often experience wetter than average conditions during La Niña years. This can lead to flooding and landslides, which disrupt agriculture, infrastructure, and daily life. For example, heavy rains during La Niña have historically caused severe floods in countries like Indonesia and the Philippines. On the other hand, La Niña creates drier than usual conditions in other parts of the world. Regions such as southern South America, parts of the United States, and the Horn of Africa often face droughts during La Niña events. These dry spells can devastate crops, reduce water supplies, and trigger food shortages. La Niña also influences hurricane activity. In the Atlantic Ocean, La Niña tends to create favorable conditions for the development of hurricanes by reducing wind shear, which allows storms to strengthen. This has led to more active and intense hurricane seasons during La Niña years. In contrast, the Pacific Basin may see fewer typhoons due to the cooling effect. In North America, La Niña can cause colder, snowier winters in the northern United States and milder, drier conditions in the southern states. This variability can strain infrastructure and impact energy demands. Beyond weather, La Niña affects ecosystems. For example, colder ocean temperatures disrupt marine life, affecting fish populations and coral reefs. In turn, this impacts fishing communities and global seafood supplies. The far-reaching effects of La Niña demonstrate its power to reshape weather patterns and ecosystems worldwide, making it a key focus for climate researchers and policymakers. Throughout history, La Niña has been associated with extreme weather events and significant impacts across the globe. One of the most devastating La Niña events occurred from 1998 to 2001, which caused widespread flooding in Southeast Asia and severe droughts in parts of Africa and South America. Countries like Indonesia and Bangladesh experienced record-breaking rainfall, leading to catastrophic floods, displacement, and loss of life. In contrast, South America suffered devastating droughts during the same event, particularly in Brazil and Argentina. These droughts caused agricultural losses worth billions of dollars, affecting global food markets. The Horn of Africa also experienced prolonged dry conditions, leading to water scarcity, famine, and humanitarian crises. Another notable La Niña event happened in 2010-2011, which brought massive flooding to Australia. Entire towns were submerged, and the agricultural sector faced heavy losses as crops were destroyed. This event also intensified the Atlantic hurricane season, resulting in powerful storms that caused destruction across the Caribbean and the southeastern United States. Even marine ecosystems have felt the effects of La Niña. During these events, the cooler ocean waters have disrupted marine food chains, affecting fish populations and industries dependent on fishing. These historical examples highlight how La Niña can unleash both extreme wet and dry conditions, emphasizing the importance of preparation and adaptive strategies to minimize its impacts on vulnerable regions. Predicting and monitoring La Niña involves a combination of advanced technology and scientific models. Climate scientists use tools like satellites, ocean buoys, and temperature sensors to track changes in sea surface temperatures and atmospheric conditions over the Pacific Ocean. These observations provide crucial data that help identify the early signs of La Niña, such as strengthening trade winds and cooling waters. Sophisticated computer models also play a key role in forecasting La Niña. These models analyze vast amounts of data, including ocean temperatures, wind patterns, and historical climate trends, to predict when La Niña might develop and how long it could last. Organizations like the National Oceanic and Atmospheric Administration, NOAA, and the World Meteorological Organization, WMO, issue regular updates and outlooks based on these predictions. Despite technological advancements, challenges remain. The climate system is incredibly complex, and small variations can lead to significant changes, making precise predictions difficult. Additionally, interactions with other climate phenomena, such as global warming, can influence the intensity and frequency of La Niña events. Accurate monitoring and early forecasts are essential for governments and communities to prepare for La Niña's impacts, from extreme weather to economic disruptions. This knowledge enables better planning and helps mitigate the risks associated with this powerful climate phenomenon. Mitigating and adapting to La Niña's impacts requires a proactive approach, combining scientific research, early warning systems, and community preparedness. Governments and organizations play a vital role in developing strategies to reduce the risks associated with extreme weather events triggered by La Niña. Early warning systems are crucial. Accurate forecasts and timely dissemination of information allow communities to prepare for floods, droughts, or storms. For example, flood-prone areas can implement evacuation plans, while drought-affected regions can manage water resources more efficiently. Infrastructure resilience is another key strategy. Building stronger levees, improving drainage systems, and ensuring that homes and public buildings can withstand severe weather are practical ways to minimize damage. In agricultural sectors, adopting drought-resistant crops or improving irrigation systems can help farmers cope with dry conditions caused by La Niña. International collaboration also plays a role. Humanitarian aid and resource sharing among nations can support regions severely affected by La Niña, especially in developing countries. On a local level, educating communities about La Niña and its potential impacts ensures that people understand the risks and can take preventive measures. Together, these strategies help reduce the economic and human toll of La Niña, making societies more resilient to its recurring challenges. La Niña is a powerful natural phenomenon that shapes weather patterns, ecosystems, and human lives worldwide. Its cooling influence on the Pacific Ocean triggers a ripple effect, bringing heavy rains, severe droughts, and unpredictable weather to different regions. By understanding its causes and impacts, we can better prepare for the challenges it poses. Throughout history, La Niña has shown its ability to disrupt economies, ecosystems, and communities, making it essential to prioritize prediction, mitigation, and adaptation strategies. From advanced forecasting tools to community preparedness, efforts to manage La Niña's effects are crucial in reducing its risks. As climate change continues to influence global weather systems, studying La Niña becomes even more important. It reminds us of the delicate balance of our planet's climate and the need for collaboration and resilience to face future challenges.